In this video, we're looking at solving more disguised quadratic equations. Now, we are told that this is a quadratic equation that we are to solve by factorising. However, this does not look like a normal quadratic. It is a bit disguised. We want to get it into the form ax squared plus bx plus c equals 0, and then we can think about factorising the left-hand side here and then solving. So how do we turn this into something that looks more like this? Well, we can multiply the left and the right hand sides by the denominator of the fraction. If I multiply this fraction by the denominator, I am just left with the numerator. I get x squared minus 1, and that's going to equal 3 lots of this denominator, 3 minus 3x. Expanding the right hand side, I get 9 minus 9x, and now if I collect all of the terms onto the left hand side here, I'm going to get x squared plus 9x minus 10, and that equals 0. So we've got our equation into this form, ax squared plus bx plus c equals 0. From here we could solve it by completing the square or using the quadratic formula, but we're told to do this by factorising, so let's factorise it. This one factorises to x plus 10 x minus 1, and that equals 0. That means we get solutions x equals negative 10, x equals positive 1. Let's move on to the next example. Pause the video and have a go at this example for yourself. Here's how I would do this. I would multiply the left hand side and the right hand side of the equation by x squared, by this denominator. On the left hand side, I will then have 18 minus 7x over x squared multiplied by x squared, which would just give me 18 minus 7x. And on the right hand side, I would have this 1 multiplied by x squared, which just gives me x squared. Now I'm going to collect all of the terms on the right hand side here. So I'm going to have 0 on the left. I'll have x squared plus 7x minus 18 on the right. Now this expression on the right factorizes into x plus 9 x minus 2, which means my solutions are x equals negative 9, x equals 2.